So in the last class we are going through caching, first level and second level caching. We saw first level cache. So first level cache, as I told you people, it is used by the session to manage the entity object state, and also one more thing, you'll find that here to optimize the query generation and all, even for that purpose, the second level, sorry, session uses this first level cache, or we say persistent content. Okay, yeah. So hi Niharika, good evening. We're just starting. Yeah. So now we'll talk about second level cache. Second level cache, we did had some discussion in the last class. Second level cache is associated to session or session factory. Session factory object. It is actually associated to session factory object here. Yes. So you know, second level cache, as I told you people, we have several cache implementations for the second level cache, and I was showing you people how to enable second level cache and how to use one of the cache implementations. So what is the cache implementations? We have several. There are several cache implementations: EH cache, OS cache, SRAM cache, JBoss tree cache, the commercial caches also. Okay, so this is EH cache. Okay, you see, first of all, we'll add this dependency, EH cache dependency, and next here in the Hibernate configuration file, yes, we have enabled the second level cache. How to enable second level cache? This is what we'll do. Okay, next thing, You see, if you want to use EH cache, this is how you'll configure EH cache. This is how you have to configure EH cache. So that it is one of the classes. So basically, which is provided by the EH cache people itself. EH cache region factory class. So we have to configure it here. Next, to work with EH cache, so we need a special configuration file here, ehcache.xml. See, I got this file from the EH cache people itself. EH cache people itself will provide you this configuration file. Okay, and we can edit it according to our requirements. We can edit this configuration file according to our requirements. I can say yes. Next thing, first of all, before we move any further, I would like to talk about caching strategies. So we got some strategies which we need to discuss. Please do that. Just a minute, please. Just a minute. Yeah, sorry. Just a minute. More, please. Yeah. See, we have something called as caching strategies, which are basically important here for cache providers. Okay. For the cache implementation, here, this caching strategies are important. So basically, we need to configure this information. You'll find that the entity objects, they are classified into different types here. Okay, based on the kind of operations which you perform on those objects. You see, we have read only. first of all. So read-only caching strategy, if you can check this here, see, that means generally we can configure this strategies on the objects. Generally we'll be configuring the strategies on the objects, I can say. See, if your application needs to read but not modify the instances of a persistence class, that means entity objects, I can say in other words. So a read-only cache is best choice. Yeah, an application can still delete entities, and these changes should be reflected in second level cache so that the cache does not provide stale entities. Yes. So I will show you how to configure this caching strategies here. So if you take this case study which we are working with, so let's take categories. Yeah, I can say categories is the best choice. If you have category objects, so what is the kind of or nature of operation we perform on the category objects? What is the nature of operation we perform on the category objects? I mean, will you frequently read them, update them, the application? Will it be frequently reading them, updating them, deleting them? What it does?
Frequently read them.
Reading. Yes, that is the most common operation will be performing on that objects. Yes, the read operation. So you can actually configure the details here. Yes, how you want the cache when these objects are cached, how you want the cache to manage these objects. You can just configure the details. Okay, using this annotation. Cache usage equal to read only. Then you have region. Region, let's say something like this. I'll tell you. Don't worry about region. Just check this. So we have configured the strategy as read only. That means by adding this annotation on top of this object, you're saying that here, yes, this objects will be cached, and the applications generally will be performing read-only operation on this objects. Application will be performing read-only operation on this objects. Yes. Okay. So how it will be useful for the cache? What do people think? How this information will be useful for the cache?
Maybe if this is operation read only, it might store this in the ROM memory, read only memory. Cache might configure this in the read only memory.
No. Actually, what happens, I'll tell you. First of all, when we talk about cache, you need to also understand one more thing. As we have discussed, so cache is a memory, it's primary memory itself, where your objects which are loaded from the database will be stored. The records which are fetched, transformed into objects. You see, that objects which are loaded from the database will be cached here. A copy of that object is created and it is stored in the cache. So we have only copy of that record. The cached object basically it represents that record. It's a copy of record. Original object is still in the database server itself. Original record, I'm sorry. Original record is still in the database server. Yes. You'll find that original record is actually in the database server itself. Yes. Here, but there is an issue with this caching. What is it? You have cached an object. Okay, you got a copy of that record in the cache. What if that original object is modified or updated in the database server? Some other application or some other source is modifying that record, original record in the database server. Then what? Here, the original record is modified in the database server. That means now we got a copy of record in the cache, now which is stale data, I can say. This copy of record which I got here in the cache, it is actually stale data. Yes. Okay. So even vice versa also is possible. That means the application will be working with this cached objects, assuming that this is the original record in the database server, right? So it will be modifying this object in the cache. So that application wants to modify the record in the database server. So it will modify this object in the cache. Now this object has been modified and this changes have to be synced with the database server. Okay, yes, because that is the application's intention. So if that record, if this object cached object state is not updated in the database server, even that is going to be an issue, right? Yes. So here you see application is supposed, here you see this is the issue which you'll see with caching. You may have stale data because you have cached an object. If it is updated in the database server, if the record is updated in the database server, right? Or what if the record is deleted? In that case also, you see, now in the database we don't have a record, original record, but you have a copy of that record here in the cache. Yes, it is not supposed to be available now, right? So you see, the cache implementations will take care of it. They'll make sure that the records are. It will try to check with the database server, okay, and it will try to accordingly update this information here. See, this is where your caching strategies will help. This way, the caching strategies will help the cache implementation to maintain this cached objects. For example, if I configure this object, if I configure this object as read-only object, you see, we are configuring it as read-only. What does that means? So this object is it is never modified. Actually, it is never modified. If it is never modified, now the cache implementation here, so it need not worry about, now the cache need not worry about checking whether this record is modified in the database server or not, right? Once it loads this object, you see, it can just forget about this object here because it will be never synchronized. It doesn't need any synchronization at all. Yes, because application won't modify this object. Even this record associated to this object in the database will not be modified. So it can forget about this object. Okay. This object might be deleted. In that case, it has to be removed. That's it. I mean, the record associated with this object is deleted from the database. In that case, it has to be deleted. So I hope you people got this point, all of you. Is it clear how the strategies will help the cache implementation? Okay. Now, similarly, we have other strategies also. Let's check this. We have read write also. So applications will be frequently updating a record, modifying some types of records. Not only modifying them, they'll read that records also very frequently. So uh, now you check this case study, our case study itself. You check our case study and tell me which objects are frequently modified here. Yes, which objects are frequently modified. Bits. Once a bit is placed, I guess it is not modified frequently. Mm, I can say bidder, not bidder, sellers. You can take the seller. You see, I can say that seller's commission rate may change. Max items allowed, even this may change here. Yes. Am I out? Am I right? So you see, based on the feedback, so customers, let's say, will be giving the feedback based on that the sellers are rated, and based on the ratings of that seller, let's say you see the commission rate for that seller, and also the max items the seller can sell will change. Let's say dynamically. Yeah. So you got this point. I can say this object will be updated frequently. Is it clear? So this type of objects here, you see, we'll configure them using read write strategy. Read write. Yeah. What if we configure it as read write here? Yes. You see, in this case, the cache, what it does, it will frequently check with the database server whether these records are updated or modified in the database server. Okay, whether they are modified or updated in the database server. If so, it will try to synchronize the changes here accordingly. Here, you know, why it does that? Because these objects are frequently modified or updated, right? These objects are frequently modified or updated. So that's the reason why, see, accordingly, it will manage that. Next,
Uh, what is users region in this one?
yeah, region we'll see. We'll see. I'll talk about it. Okay. Yeah, region I'll tell you. The region is just is used to just group the cached objects in the cache. So when I'll show you that cache XML file configuration file. We'll see that over there. So next thing, we have something called as non-strict read write. Okay, non-strict read write. The name itself indicates. What do people think? Non-strict read write. Let's see. Similar to read write strategy, there might be occasional stale read upon concurrent access to the entity. That means occasionally this record will be read or modified here. Okay, that is a non-strict read write. Okay, so that means here for the cache implementation, you need not frequently check with the database whether the objects have been modified, right? Because they are done frequently, right? So, so what do people think? Which objects are frequently or occasionally modified from these examples, from these entities which you got here? Which objects are occasionally modified? Yes. So here, in this case, I can say address. I can say address, right? Address we can say because users will be they won't frequently change the address, but occasionally they'll be changing it, right? So when users, when they move to a different place, their billing address or shipping address will change. Not every time, right? Yes. Yeah. So such objects we can configure them as non-strict read write, cache usage equal to non-strict read write. Reason, let's say users. And talk about region later. Next, the last type of strategy, transactional reset. What is this transactional here? You see, when we talk about transactional, generally these are the objects where there is a chance that multiple transactions may concurrently operate on this object. Multiple transactions may concurrently operate on this object here. So not all caches support transactions. Okay. Yes. If OS cache, RAM cache doesn't. You see, cache provides some support. Now, which um, objects would be transactional here? Because in this case, we don't have such objects. Yeah, we don't have such objects here. So basically, you know, you can configure it as transactional. Once you do it, you see, the cache will make sure that appropriate measures are taken so that there won't be any collisions or isolation issues which we discussed earlier. So we have discussed about the isolation issues, right? Yes. So you'll find that there won't be any such issues. Yes. Okay. So these are the caching strategies which which helps the cache implementation to understand how to maintain these objects based on the nature of operations which are performed on these objects. As you say. Yes. Based on the nature of operations, you see, accordingly the cache implementation will maintain these objects. So now we have an important file, as I told you before. So this will give you a complete clear picture of you know how the cache will manage these objects internally. Okay. Yes. You see, in this XML file, generally you'll configure the cached object. How generally you'll configure the details about how you want the cache implementation to maintain these objects. How you want the cache implementation here to maintain these objects. You see, we have this element called as default cache, which is a default configuration for all the entity objects which are cached here. So first of all, you see you got this max elements in the memory. Max elements in the memory. So max elements in the memory is 10,000. That means you want cache implementation to have maximum of 10,000 objects in the cache. There should be how many objects in the cache? 10,000 objects in the cache. You want 10,000 objects in the cache. So here eternal equal to false. What this eternal equal to false means here? You see, that means whether the objects which are cached, whether these objects can be removed from the cache if needed. Okay, if needed, the objects, whether they have to be removed, whether they can be removed from the cache or not. Here you see, in this case it is false. That means yes, these objects can be removed from the cache based on the requirement. It accommodates new objects. Why these objects have to be removed? Why these objects have to be removed? You see, because to accommodate new objects. In order to accommodate new objects, the existing objects have to be removed. Yes, whether that existing objects which are cached can be removed or not, that is specified by this eternal. Next, we have time to idle seconds. Time to idle seconds means, you see, the object which is cached, how long it can sit idle. That means if that object is not used, the cached object, if it is not used here, for 120 milliseconds, 120 seconds, not milliseconds, I'm sorry. If the cached object is not used for 120 seconds, then I can say it is idle for 120 seconds here. So if it is idle for 120 seconds, you can simply remove it. Okay. Yes. So you're asking the cache implementation to remove it here. That is what it indicates. Okay. That is what it includes. Next, time to live seconds. You see the cached object, this is just sample data, that's it, okay? If the cached object, once the object is cached, how long it has to be retained in the cache? How long that object which is cached should be retained in the cache? It is 120 seconds, not more than 120 seconds. That is what it indicates. Okay. Next, overflow to disk. Overflow to disk. Just a minute, please. Sorry. Yeah. So you see, for suppose, what if the memory is full? What if that primary memory is full? You see, for the cache, part of memory is allocated, not complete memory. So you see, if the memory is full, in that case, can we write these objects to the secondary storage? That means to the hard disk. So primary memory, it's ROM. Applications will be using primary memory. But now you see here, can we write them or can we save them to the cache, secondary storage? You can say here in this case it is set to true. We can do that. Yes. Okay. So this is for default configuration for all the objects which you got. Yes. Next, you see, for a particular region, you know what? We can group objects, similar objects together. We can actually group similar objects together. Here, we call it as a region. You see, for example, I did that. So sellers I've added it to users region. Address also added it to users region. So item I've added it to item, not item category, I've added it to inventory region. This way it is possible to group this objects, I can say. So now based on the region, you see we have this configurations here. You see categories, it's the region name actually. I will make it users, let's say. So the objects which belong to a particular region, how you want to manage them. I mean, how many objects you want to retain here. You see, we want 500 objects of that particular type. You say, I want 1500 or 2500 objects of that particular type. I mean, the objects which belong to that region. They should be 2500, let's say. Yes. Eternal equals to false. So in this case, that means yes, this objects which are cached, whether they have to be retained till the cache is up and running, or they can be removed in between. That is what it indicates. Okay, that is eternal. So I hope you got it, all of it. So next, we have time to idle settings. You see, this objects which belong to this user's region, how long they have to be retained for 300 milliseconds if they are idle, if they are not used. Okay. So if this objects, if they are not used for 300 milliseconds, they have to be removed. They have to be removed. Yeah. Sorry. Okay. Similarly, time to live seconds. It is 600 milliseconds. 600 seconds. I'm sorry. Overflow to disk. Yes, they can be written to the secondary storage. Similarly, see, we have another cache region configuration here. For example, inventory cache region. We call it as inventory. So in this case, you see how many objects we want of this particular type. You see, what if the time to idle seconds is 0? That means you can just you want this objects will just stay in the memory like that. That's it. They will never expire. Okay, those objects will never expire in future. That is what it indicates. I hope you got it. So, anyone got any questions in this regard? Please let me know. Just a minute. So, anyone got any questions?
Um, Actually, when will this caching process all will be included in a project after implementing all the project, or how does this happen in a real environment?
See, it's not about when it is done. Generally, now when we have implemented it, you see, so we have developed this application. So Yeah, in the production you can do it. So definitely, even in the testing for performance and all, to check the performance, yes, initially you can do it. In the development also, for testing purpose also, you can do that. Yes, it is possible. And then when this application is moved to the production, at that time you can configure this cache. Yes, but for testing, for developing also, you have to test it right after configuring it. For testing also, it is definitely yes. Yes. At that time also, you can configure it. Yes. So,
Okay, sir. Thank you.
still anyone got any doubts? So, you know, people may argue with you. People argue that Hibernate, has got an issue. Yes, of course. What is it here? Hibernate is adding an additional layer, right? So when we talk about plain JDBC, see, we don't have that issue. But what's Hibernate doing here? It is adding an additional layer, I can say. It's in between, right? So as a result of it, see, applications which use Hibernate are considered a little slow compared to JDBC API. But how can we address this issue? What do you people think? How can we address this issue?
Sir, actually caching is used to improve the performance speed, right? Is used to speed up the application for database access, right?
Yes, yeah. So this is how, with the help of caching, you see, to some extent, we can, improvise the performance of the application. So generally, for JDBC, we don't have that option. So what you can do here, you see, we can easily plug in third-party implementation, cache implementation. Yes, we can improvise the application's performance because you see, now the number of DB interactions will be reduced. The number of DB hits will be reduced here. As a result of it, the applications will be a little faster. Yes. But you see, one more thing. There is an advantage of using Hibernate framework over plain JDBC, right? So even considering the advantages of Hibernate framework, so we can say it's a trade-off. Uh, what are the advantages you found with Hibernate framework so far? Yes. What are the various advantages you found with Hibernate framework? So the redundancy can be reduced. Yeah, resource management, it helps us to manage associations, right? And it makes the applications database independent, not dependent. helps us to manage inheritance relationships. There are several advantages, right? So I will try to show you people by running a test case. We'll try to see the timing dependencies. I mean, what will be the difference time taken to fetch the records from the database server and time taken to fetch the records from the Java, from the cache. I wanted to demonstrate that example. I'll do it soon. So an important notice tomorrow. Actually, I'm planning a special class for web development. Okay, so far we didn't go through this web development, right? So tomorrow I'm planning a special class of at least 3 hours for 3 hours class. Okay, so I want you people to make yourself available to day after tomorrow also. Okay. Okay. So are you people available Saturday and Sunday? Okay. Because we had some break between, over the week, year ending. How many of you people are available? Just type in yes or no. I want you people to please cooperate with me and make yourself available so that we can just spend some time to cover this topics. Good, great. So I'll do this. Tomorrow I'll start the class at, okay, but please, I want this on Sunday at the rate 5 a.m. Indian time and take a class of how many hours? Of 3 hours. So what I'll be talking about, this will be completely web development. So where first I'll introduce you people to web applications development, okay, and various elements of web application development. And I'll give you a high-level overview of servlets also. We'll see some programming related to servlets. And on the on the UI side also, okay. And one more class I wanted to conduct it on Monday at the rate what time? Monday means your Sunday, so US related Sunday. Sunday evening, that means around same time. So let's try to have a class. Okay. So in this class also, it will be, I'll make it again 2 to 3 hours class. Okay. 3 hours session. So where I'll be talking about the same front end technologies like HTML, JavaScript. Especially, I'll be concentrating more on JavaScript. Okay. And HTML, I'll introduce you people definitely. I'll make you people work on it. I'll be giving you some tasks on it. JavaScript, I will give you, I'll teach you to good extent, including Ajax and all. And later on, we'll go with jQuery and all. So now, from now on, I'll be planning for the weekends for this UI technologies. Okay, whenever it is possible. So we'll try to have some additional hours. So this weekend, so this is my plan. Okay, yeah. So we'll be covering web development special classes on this. Okay, so where I'll be talking about HTTP protocol. So overall everything. So we'll see. I'll give you a complete overview of what is this web application development in the first session and servlet programming, and then in the second session I'll talk about HTML, JavaScript. Okay, yes, fine. So please make yourself available to the maximum possibility. Try your best to attend this classes. Okay, yes. So because from next week onwards, I'll be starting with web services followed by Spring MVC and all, where we'll see web application development, front-end technologies, back-end technologies, everything is immersed. Almost, you see, we saw this persistence and all. Next thing will be concentrating on the business logic now. Okay, how to develop this business logic and make it available through the services. In that is where your REST SOAP services comes into the picture. Then we'll talk about Spring framework. So that is also related to enterprise application development. It provides overall support for development of enterprise applications, where you'll see, the various ways to effectively develop the applications by using different features of Spring, and all such things we'll discuss. Okay. Yes. Fine. So that's all for today. I'll stop it here early because I'm taking a long sessions tomorrow and after tomorrow. I should have to inform you people at least one day before. I'm sorry, but next week I'll do it. Next weekend, clear notice I'll give you at least 2-3 days before it goes. Okay. Yeah. So thank you all. Bye bye. So I'll stop it here today. And I guess I need one more class for Hibernate framework. Then I'll close it. Okay. Thank you all. Bye bye.